Hello everyone. You've been enjoying it, haven't you? Be honest. You've had a nice rest from this maths exam. And if you've seen my post on YouTube, you can see that we're in the middle of a decent sized gap between the first and the second exam. But here, upon us, very shortly in 9 days, is the exam number 2. Now I had a little poll, and these two topics are coming out in the front, so I thought I'd make a couple of questions like this. So two topics, linear equations and data. And that takes us through plotting those linear equations, sketching them, coordinate geometry, which is essentially problem solving with it, averages, frequency tables, statistics, sampling and box plots. Wow, look at all of that to get through. So with my new antipodes, I don't know how they pronounce it, antipodes drink. I'm just going to take a swig. Yeah. Let's get started. Oh, don't forget to go to Patreon. You can get these questions for obviously for free, but you can get them and have a go at them yourself, which is way better than just watching these answers, right? So, let's get started properly. First question. And we're going to do these fairly thoroughly. Where I think it's appropriate, we'll look at a bit of background, because I'm not going to assume that we're here because we know exactly what we're doing. Not exactly. Anyway, so bear with me. Find the equation of the two lines that intersect at point 3,3. Okay, so we can find point 3,3. Here is 3 across and 3 up. So we're talking about this point here, and therefore we're talking about the blue and the red line. So let's start with the blue line. When we're forming these equations, or we want to know which equation is which, the straight line has two defining characteristics. It has a gradient, which is how steep it's going. Sometimes you could think about it as the direction. And C, which is where it crosses the y-axis. So those are the two things. And if you know those two things, you can define that line. So we can work backwards. Instead of drawing this thing, we're going to look for it in the diagram. We can see the blue one. Let's start with the blue first. That has crossed over at -3. Just like that. And so in this case, blue has an a C of -3, because that's where it crosses the y-intercept. And to find the gradient is defined by how much your line goes up as you go cross 1 from left to right. Okay, so how much has it gone up? Easy to do, just pick a point. So let's zoom in for this one, if I can. How do I... There you go. So I'm going to pick a point that is on a nice whole number, like here. There's my picked point. And if I go across 1, my question is, how has the blue line changed if I now go straight to it? It looks as though it's gone up 2. You can see maybe if we went across 1, it could have gone down. First of all, you see if it goes up, it's positive. So it's positive 2 is what we're looking at there. Actually can't see it very well. Let's put it over here. Maybe I want to put that. Anyway, this is fine. So if this goes across 1, it goes up 2. So we can say that the gradient is 2. Why do you do this? What is this skill? This skill is being able to sketch quadratics. So you're picking up on the key characteristics. You can circle. All right, so now we'll look at the red. The red crosses in a positive, so 1, 2, 3, 4. So this time C is 4. And we're looking for gradient. This is really cool to see it because, wow, this one's a bit harder. If we do the same rule that I said to you last time, pick a point. Let's pick a point like down here so it's out of the way. And we'll zoom in to see. So if we pick this point and we go across 1, how far is that down? Now a lot of people are very quick to guess and they'll say, oh, it's a third. Oh, it's a half or whatever. But let's be real, you don't know where that is exactly. Unless you go across until you get to the nearest whole number that you would go down, which is clearly here. Now, the way we think about this is not like, if I go across 1, how much have I gone down? Because I don't know what that number is. But if we look about it in a different way, that I've taken 3 to go down 1, that means, because it's linear, this is exactly 1/3 because I've taken 3 moves to get down 1 whole. So that is like dividing 1 by 3. But if we want to be a bit more like sophisticated, we can look at the gradient as the difference in y divided by the difference in x. Okay, so looking at the first gradient that we did, that we drew a triangle for that connected the 2 whole points. It had a difference, I can't really see that, let's put it here. It had a difference in y of 2, it went up 2, positive 2, and it went across 1. So that was the difference in x, they cross. So this gradient would have been 2 divided by 1, which was 2. That's good, we knew it was 2. Let's do dy by dx for the second one, which is probably, if we're stuck about like how to do it, if we're stuck trying to count or it's too hard, or we're only given 2 coordinates, it's much better to think about it as dy divided by dx. So in this case, dy is not going up, it's actually going down. So this is if we read from left to right. So we started here, and we're going to go right and down. So this is a -1, but it is 3 across in the positive direction, which is to the right. And all of these are going to be positive for the x. The only difference is whether the y has gone down or up, because we're always going to read left to right. So the dy here is -1. And the dx is 3. So you can write this in a number of ways. You can write -1/3 up to you. There we go. So what was really good about that one is seeing that you can't just go across 1. Sometimes you have to go across a few in order to go down 1, and that implies something about the fraction. But a better way is to do dy divided by dx. And it just throws you off. But as long as you follow that method every single time, you're going to be good. Okay, so find the equation of the 2 lines. Done. No, we're not. This is y equals 2x minus 3. This is y equals -1/3 x plus 4. Now in maths we don't really like to have this negative out the front, and this is where in the exam it will make you feel a little bit weird when they write the equation like this. So it's the same thing. It's still -1/3 x, but the -1/3 x is being written on the right. and it's still plus 4, but because it's being written at the front, you don't need to write plus. And in that regard, you've got one less thing to write. It's seen as a little bit neater. Okay, complete the table for the equation y plus x equals 1. So all across this table, there are pairs, 4, 5, 6 pairs. And all of those pairs of x and y, when you add them together, they'll equal 1. That's me reading this equation. It says when you add them together, it equals 1. Now, some people like to rearrange this equation. If they're trying to find a missing x, they'll say x equals 1 minus y. And if they're trying to find a missing y, they'll rearrange it so it's 1 minus x. And then they'll work individually. I don't think it's necessary, unless you really want to. But both of these numbers must add up to 1. That's fun. We can do that. Minus 3 plus the missing y will give 1. We need to add 4, don't we? 2 plus something equals 1. Oh, okay. Don't get carried away with the add, okay? It could go down. It could be negative. Something. Okay, so 0 plus something equals 1. Must be 1. And the same the other way around. And 5 plus, again, that's going to be a negative, isn't it? Negative 4. In order to get to 1. So we've got a set of coordinates now. We want to plot the equation. So here's the difference. What we were doing earlier was sketching, because there's no real numbers involved except the points where we cross the axis. So we only cared about the intercept and the gradient. In this case, we're told to plot it. Plotting is where you plot every one of these coordinates and join it up. It's very different to sketching, because plotting you need a proper axes and numbers. With sketching you don't. Okay, so in this I'm not going to draw the numbers on, just a few to show. 1, 2, 3, 4, 5. That's 5, 6, 7, etc. Just a few markers. That's 5, 2, 3, 4, 5. We'll just get a few in there. Okay, so now we'll plot them. Should we use a different color? Orange. First one, minus 5, 6. Minus 5, 1, 2, 3, 4, 5, 6. Minus 3, 4. Minus 1, 2. We don't seem to have all the points, but as long as we have at least 3, we're going to draw a really straight line. If it is a straight line, it looks like a straight line. There are clues as to why I think it's a straight line, but we're not going to go there. 0, 1. So that's the intercept. Look at that. When x equals 0, that's a good definition to write down. When x equals 0, that's for finding the intercept. Because x equals 0 runs right on that line of the y axis, and so put x equals 0 in and you'll find the intercept. Other way around, if you put y equals 0, you're going to find what the x intercept, because that's straight across. And 5 minus 4. It looks like a straight line. We now need to draw a straight line. I don't know how straight it's going to be, and it's probably going to go whoop, flying off to the side, because it thinks it has to connect with the corners of the shape. As I was pleading on my YouTube, community section, like, please Samsung, support this program again. Make it so that it actually works and it's not glitchy. Alright, I think we want it as thin as we can make it. That would be good enough. So we've plotted it. Plotted it is putting all those points on properly and joining it together with a ruler. Awesome. Making your method clear on the graph, estimate the coordinate of the intersection between the equation in part B and the equation... This is also really good to see. So you're going to see equations that don't look like what you want them to. This, for example, doesn't. But what we can do is rearrange it. So these two I want to the other side. And I'll do this one bit at a time. Now, I know sometimes it can be difficult to take on new methods, but this method is really the best. Okay, so it's the balance method. So whatever you do to one side, you do to the other. Let's do it one at a time. We're going to get rid of the 3 on the left. That means we take away 3, but we have to do it on the same on the right. It's essentially going to disappear from the left, but -3 is on the right because 0 minus 3. Now we're going to take away 4x on both sides, and that's going to be y equals -3. Well, the 4x minus 4x, that's disappearing on the left. Whatever's there already, which is -3, we're going to take away 4x from it. Now we're used to seeing this a little bit better if we write the x first. They're both negative, so what are you going to do? Let's consider what this is. This has a gradient of -4 and an intercept of -3. So let's have a look up there where this is, because we need to find the intercept with that one that we just drew and this one here that crosses the y-axis at -3 and goes down 4 at a time for every one across. Oh, look, there's already one that crosses at -3. And let's check if it goes down by 4. If we go across 1, how much has it gone down? 1, 2, 3, 4. There it is. Goes down 4 for every one across. And just to double check that, look, dy by dx, we would do 4 divided by 1. But that's not 4, it's -4. So it goes down, equals -4. Yeah, there you go. It's got a gradient of -4. So it's this purple one. Let's read the question again. Making your method clear on the graph, estimate the coordinate of the intersection. So we have to make it clear that we're estimating the coordinate of the intersection. So it's the purple with the yellow. I feel like the yellow, maybe we could adjust that perfectly so it goes through the corners properly. Yeah, okay, that's good. Okay, so let's have a little zoom in and see. Ooh, yeah. How do we make this clear on the graph? Let's use a decent color. Probably don't need to be writing that big, that's fine. Oh, no, it's not a decent color. I've already used it. Let's use like a pink. This. So the intersection of these two graphs, as you can see, is around here. But it says we've got to make our method clear on the graph. It's not about finding it exactly because it's estimation. So my method is to find the point of intersection essentially solving this. And to draw a dotted line with the ruler, preferably, straight down to here. Now I know this is -1. And this is -2. So I'm thinking if there's the middle point, it's half of that, it's -1.25. I thought I turned finger drawing off. Anyway, I will use the mouse. We're going to say approximately equal to -1.25. Now we can like find this exactly if we just put the two graphs equal. That's not what they're asking us to do, but if we've got y plus x equals 1, that's y equals 1 minus x. We could put them together. 1 minus x equals minus 4x minus 3. So what I did there was this and this is equal to y, so I put them equal to each other. Okay, so I'm going to move the 4x over to the right, to the left, as in add 4x to both sides, and then probably going to take away 1 like this. Yep, happy with that. And then essentially divide it, which is -1.3 recurring. So I wasn't too bad. I'd definitely get away with that in the exam, but that's if you want to find it exact. But it says here, making method clear on the graph, estimate. Estimate, you don't get marks for giving the exact number. They don't care about the exact number. This is an algebraic method. They're really testing if you can find that point and estimate. Okay, let's have a look at our next question. We'll go to the top so that it's right there for us. Find the equation of the line perpendicular. This is perpendicular, 90 degrees, to this equation, passing through the midpoint of AB, where A is this and B is this. Whew, okay. Well, this is the thing. In order to figure out an equation, you need M and you need C, okay, intercept and gradient. And there's a lot of clues here that can help us. There's another way of doing it. If you have coordinates, coordinates can help you. Let's say you have M and a coordinate, then those two things, if you add them together, they will find this intercept. So it's not all lost. It looks as though we've got here a gradient and we have a coordinate. Let's just see how that plays out. So if we know we're looking for the equation which is perpendicular to this, let's first of all use a little trick. With this equation, the gradient is 4. It's the coefficient of x, it's the number in front of x, as long as y is on its own. Okay, so if you get it in the format y equals, you could just look at the number in front of the x and that's going to be your gradient. So if m is 4, the gradient of a perpendicular line to this, so one that's going this way is ours, and a perpendicular line is at 90 degrees, the relationship is that it's the negative reciprocal. So we'll call this gradient m1, and the m perpendicular, so the gradient of the perpendicular, is equal to -1/4. Now in previous videos we've looked at what a reciprocal is. For numbers, it's just 1/. For fractions, you flip them upside down. And so we also add the negative. Kind of makes sense. If one's going this way, it's positive gradient. The other one has to be a negative gradient going this way. So it's the negative reciprocal. So we know something about this new line we're about to find. But if we put it into the equation, y equals negative 1 over 4x. We still don't know what c is. We in fact have three unknowns. The y, the x, and the c. Three unknowns is way too much to deal with. There is something else that we can do. It says that it goes through the midpoint of AB. I'm curious what the midpoint of AB is to begin with. I always love a good visual, so I'm going to draw AB. If A is here at -5, -3, which direction is B? B is -1, so it's actually further to the right. And if we have, looking at how much higher it is, B is 3 and it down A is -3, so it goes up. So we can roughly draw it without having to do it exact. -1, 3. And we could join that together and give us a nice visual. So this is where it is, and it's nice to draw a triangle to find the midpoint, because I feel like it's nice and methodical. The distance that this went in terms of the height went from -3 to +3, so this is a height of 6. From -5 to -1 is 4, so it has a distance of 4 along the bottom. To go halfway up this triangle, instead of all the way up this diagonal here, to only go halfway up, you only need to go halfway up this one side and halfway up this side. So instead of going across 4, we're going to go across 2. Instead of going up 6, we're going to go up 3. And that's where we're going to find our midpoint. So going from -5, -3, and this one, -5, is going to go up 2, and this -3 is going to go up 3. This is going to lead to a coordinate of -3, 0. It kind of makes sense when you look at it. So this is our coordinate that our line goes through. This is really useful, huh? If we have an x and a y, that if we put it into this equation, it's going to satisfy it. That means that we've eliminated x and the y. We're left with the one unknown. We can solve this. So let's put y in and x. And our remaining plus c is just there. We don't know what it is. So we can do a bit of multiplication here. We've got negative and negative make a plus. So that's a 3/4 plus c. And we need to take that to the other side. Negative 3/4. Lovely. We found c. So let's write it one more time. -1 over 4x minus 3 over 4. And we found the equation. We know we found it when we have m and c. Look how useful it is to know a coordinate. A coordinate allows us to get rid of x and y and find the unknown in the case where we had 3 things that were just unknown. Okay, we could tidy that up. We could take a -1/4 out, and that would be x. Take away 3. I say it's tidier, but it's really up to the individual. That should be x plus 3, because negative. Maybe I do like that better. But yeah, that's the equation of the line perpendicular. So there's the thing to note. For perpendicular lines, It's the negative reciprocal. That's the link between the two gradients. And then, when you know one, which is the gradient, use a coordinate. Then you'll find C. Nothing more said about that. If you have any questions, do let me know. Appreciate you all here. It's, where's my mouse? It is, 11:30 where I am in the night. Might be about midday where you are. Saturday, had enough, tired as hell from the exams during the week. I feel that. But this is recorded. You can come back and look at it whenever you want. You can listen to it sped up if you come back. Sometimes that's good. You can listen to it slow down. And sometimes we need that. Lots of pauses more like. But let's get going to our next question. Otherwise we'll be here forever. Find the equation of the perpendicular bisector of the line segment joining the 2 points M43 and N85. Oh my golly gosh. These are fun. They're actually fun, aren't they? Come on. They're okay. You get fluent at them. Find the equation of perpendicular bisector of the line segment that joins... Right, so like, you know what I'm like. I'm going to draw this. So 4, 3 is M. Let's call it this. And N would be going further along, because 8, and then further up. So it's like here again. And we shall join, like so. And we want the equation of the perpendicular bisector of this line. That's tough. That's tough, but we can do it. Remembering what we need, okay? For any equation, we're going to need a gradient, M, and an intercept, C. And when you mention perpendicular, we're going to be using that idea of the negative reciprocal. We're also going to be looking at here how to find the gradient using two coordinates, because you can tell how steep this thing is as long as you've got two coordinates on the line, and we do. So we do the same trick we had last time. 4 to 8, that's 4 across. 3 to 5, that's 2 up. And remember that the gradient was the difference in y divided by difference in x. So that's 2 over 4, which is a half. It's at this point where you think, oh, that can't be right. It's a fraction. And I hate fractions. Well, fractions are good. Okay, trust me. So with this, get this wire out of my face, hold on. Yeah, that's better. So with this gradient, this is the gradient from M to M, M to N. And just for the sake of it, we'll call it the first gradient, M1. Okay, so that's fairly important, because we know that the gradient of the perpendicular is going to be the negative reciprocal. So 1 over 2, you flip it upside down, that's 2 over 1, which is 2, and you make it negative. So we know the gradient of our line that we want. And the difference, I think the one thing you need to know is a perpendicular bisector, this word bi, it means you're going to cut it in two. So actually it means right down the middle. So here is the midpoint, and again we're looking for this line which goes through here. We have that it's y equals minus 2x plus c, but we need a coordinate. We know that this is the midpoint of that line. So instead of going, I suppose there's a couple of ways of doing it, but instead of going across 4, we'll go across 2. So this has an x of 6, and instead of going up 2, it's going to go up 1. So we have like a coordinate. So we're going to put that in, because that's x and y for us. So y is 4, minus 2 times 6, because x is 6, plus c. Scroll down a bit of space. I'd love to cut a long story short here, but we're going to do it properly and thoroughly. Yeah, that's good. And then we're going to add 4, so 16. C is 16? Yeah, I suppose it's fine. Makes sense. Looks like it's going up pretty high. It's always got to make some sense. Maybe not always full sense, but it's got to at least be possible. There you go. Found the gradient and the intercept. That's all you needed. Never fret. So that's good practice of a skill that's like very common in the exam, and it uses a different type of thing, like a perpendicular bisector. I wonder how many people knew about the fact that it was the midpoint, or did we forget? And did you even remember the perpendicular bisector? It's one of those lessons where you're taught, like you've got a ruler and you're doing this little method with a compass. Yeah, it's one of those easily forgettable lessons. So I appreciate that it may not be in the forefront of your mind. Find the area enclosed by the line in part A. That'd be really nice to know what that line's doing. What is that line in part A? So let's draw a quick sketch. It crosses the intercept at 16. It crosses the y-axis at 16. And it goes down at -2. So it's approximately... It's not... Oh, here's a fact. If a gradient equals 1, that's like this, it actually is it's 45 degrees. Which can be useful to know in terms of like rough estimation. So in this case, we're going down 2x, so it's actually about 67 degrees. If you can figure that out in your head, but it's in a sketch anyway. Ah, nice. It looks like this. Find the area enclosed by the line in part A. Okay, we've got that. That's one of the boundaries. Let's highlight it as a boundary. The line y equals 2x plus 2. So this has an intercept of 2, so it's going to be a wee bit down here. And it's got a gradient of 2, so it's just like this one. Instead of 45, we'll go up at 67 degrees. Something like that. And that's also a boundary. So the area enclosed by these two lines and the line y equals 0. So that's weird. Essentially this here. We're looking for that area. Okay, I've never seen a question like this before, but hey, let's go with it. Let's roll with the punches. What would be really nice, think about it, it looks like a triangle. So what we want is some coordinates, right? We want to know probably these. I think all of them would be useful. So let's find the coordinates of where these are crossing. This top one, it might be the easiest one. It's where the two equations are equal. So what's the other equation's just up there. That's cool. We'll put them equal to each other and find out the x value. So 2x plus 2 is equal to minus 2x plus 16. Yeah. Let's rearrange. So we've got 4x equals 14. and then x equals 14 over 4, which is 3 times for 12, 0.5. All right, 3.5. We don't, like, this is the easiest part, I suppose. To find the y coordinate, just put it into the easiest of the equations. So I'm going to pick 2x plus 2. So 2 times 3.5 plus 2. That's 7 plus 2, that's 9. So we have a height there of 9. That's really useful. So let's remind ourselves of the area of a triangle. That's a half AB. We're going to find a, let's unpack that. A half times the perpendicular height times the base. So that's what we're looking for here, perpendicular height. We've already got the perpendicular height. That's the height here. We already know that that's 9. Okay, so that's really important to us. 9. What we don't have is the base, so it's probably not a fancy way of doing this, but if we find the x-coordinate of these two, we could find that distance. That's what I'm going for. Really cool. This whole line here is the x-axis. It's also y equals 0. So if we put y equals 0 into those two equations, we're going to find where they cross the x-axis. Let's start with the original one. Start with this one up here. 0 equals minus 2x plus 16. Move plus 2x to both sides. Hey, anomaly. X equals 8. Maybe it's like one of those interstellar things. It's not an anomaly, it's just somebody trying to contact me from the future. If you've seen the film. Where are we? X equals 8. We don't need to go much further. We don't need to know what the y is, but we know what it is. It's 0. It's also true here that it's 0. Let's do it for the other one. Y equals, 0 equals 2x plus 2. Yes, yes, yes. 2x, we're going to take away 2 from both sides. X equals minus 1. There you go. So now we get a good idea of this length. We have a length here of 1. That really doesn't look like 1. Just going to write that. And then on the right hand side, 8. So our formula for area becomes a half times the perpendicular height of 9 times the base of also 9, which equals 81 divided by 2 is 40.5. And it doesn't specify. It's like an abstract idea, right? So we're going to write units squared. So there's the answer. So we highlight it. In amongst the trappings of everything. There we go. What an interesting question. I like that one. Alright, next one. We're flying. I have a list of 9 numbers. These 9 numbers have a mean of 7.6. What number should I add to the list to increase the mean to exactly 8? We just write down what we have, right? What do we know? I mean, it's not do something. It's not asking you to process, to plug something in a calculator. This maybe a little bit of a strange question, right? So you've got to think a bit. Just write down, brainstorm what we know. So we've got 9 numbers and they have a mean of 7.6. What does that mean? It means, it's a bad word, isn't it? Mean. It means that if we knew what all of those 9 numbers added up to and we divided them by 9, that would be equal to 7.6. And so we can actually multiply this out. If we treat it like an equation, we get times both sides by 9. And we might need a bit of a calculator help here, but 9 times 7.6 is, just write it out, 68.4. So it currently adds up to 68.4. And we're going to look now what we want it to be. What number should I add to the list to increase the mean to exactly 8? Interesting. So if it was 8 instead, let's call it y. If you add another number, it's actually out of 10, isn't it? So y divided by 10 equals 8. And we could call it x plus, we haven't got space, we could call it x plus 68.4 all over 10 equals 8. Now read this. What does it mean? It means if we add them all up, but then one part of it is unknown, but essentially those two added, all of those numbers added together, divided by 10 will give us 8. So in this scenario, we have a mean of 8. We just need to find out what x is. And thankfully, this is an equation, and there's one unknown. So all we have to do is rearrange x plus 68.4. We're going to times both sides by 10 to get rid of that fraction. That's really important. So now that 8 becomes 80 because we times it by 10, and on the left it just disappears. Now we take away 68.4 from both sides. And that's because we're doing that balance method. And we find that unknown thing that we should be adding to the total in order to give us the result, which was 8. How brilliant. We're no longer just doing what we're told, find the mean. We're actually taking it and manipulating it the way we need, sort of going backwards. So when you understand how to do the mean, that's not enough. These questions are where it's at, where you have to understand the method, like what is actually going on from that sort of meta perspective. And then you're able to put it into like an equation if there's part of it that you don't know, and then problem solve. Okay, I love playing mini golf, and one of the best, that's true, and one of the best aspects is a scorecard at the end. I played with my friend and we got the following scores. What is the modal score for each player? Well, the modal score is the most common. So for Jimmy boy, the mode is, can you see it? 4 comes twice, doesn't it? So it's definitely 4. We've got 1, we've got 2 appears twice. We've got 3 appears twice. Let's write this in order. 2, 3, 4. And we got 5 also appears twice. So 1, 2, 3, 4, 5 is appearing more common than the rest. Very interesting. Give me 1 second. Just gonna have a drink, and it takes a bit of time to get. So 1 second. Okay, that was very, very fancy water. Alright, so we found it. I know this seems weird, but you can have more than one mode. Alright, next one. George. The modal score for George... Where's my mouse back? Is, in a similar fashion... We've got two... Oh, it's got to be two. 2, 1, 2, 3, 4, 5, 6 is 2. What is the median for each player? So actually all of these are not in order. I think I can just about see it still. Okay, so we've got 1, and if I remember rightly, this is for Jim. We had all those numbers except 1 appear twice. Like so. George. 2, 2, 3, 4, 5, 6. How many 2s were there? 1, 2, 3, 4, 5, 6. And then we've got 2 3s and a 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Okay, so we've got 9. That's always good to double check. Now, what did we do that for? We put them in order because to find the median, that needs to happen to begin with. We're going to put them in order, and then we're going to find the number that's right in the middle. And that's, if we count in from the outside, that's one way of doing it. Probably the better way of doing it is to think about the location. And when there's small amount of numbers like this, it doesn't matter. But later, we're going to be looking at this in another question. So to find the location, we can do n plus 1 over 2. So we know there's 9 numbers. So it's 9 plus 1 over 2, which is 5. And that's the 5th location. That's where we're going to find the median. So instead of counting from the sides, we can just count from the left until we get to number 5. 1, 2, 3, 4, 5. It's right there. 1, 2, 3, 4, 5. Okay, so that's going to count for both because it's about the location. So we can write here, actually let's call it quartile 2 equals 3, quartile 2 equals 2. What's the mean score? Here we go. We're going to add all these up and then divide them by however many there are. So 1 plus 2 plus 2 plus 3 plus 3 plus 4 is 29. There's no worry about rushing this. We're just going to do it properly. And we're going to be very proud when we do it. 29 over 9. That's 3.2 recurring. For George, that's 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 4. And that's 22 over 9. And it's both over 9, that's easy enough. And we get 2.4 recurring. What you'll find when you're divided by 9 is that you get a lot of that. The single number recurs, like 4, 4, 4, 4, 4, 4, 5, 5, 5, 5, 5. So not unusual at all. Okay, we've got done the mean. So add them all up, divide them by how many there are. Who's the better player? And you must state why. Well, looking at the mode, it's a bit useless. They both have similar mode in one sense, but Jim has got more modes that are higher. So we tip on to say that maybe Jim is a better player here because he's got more frequently higher numbers. But what game is this? This game is golf. So actually, the quicker you do something, the better. So I'm going to say it's George. Because when you're putting on a golf course, these numbers represent how long it took you to get there. So if you're going to take longer, then you're going to be not as good. Sorry to say. Or good to know, however you want to see that. Okay, so in this sense, George again is better because his median is less. And if we look at the mean, George wins it again. Who is the better player? You must state why. We're going to say George. His lower par compared to Jim on all averages. And to be honest, if you want to be really thorough, you go through and you write them all. So you might say the mean for Jim was more than the mean for George. And you might even write it like the numbers. So for example, 3.2 recurring and 2.4. And you can go through and do each one like that. We did it like by talking, but and then because of these reasons, the less score is better. So we go with George. Find the mean average of the hat size X in this case. So look at these hat sizes. They go from 1, 2, 5, 6, 7, 8, 9, 10, 13. There's probably some in between, but these people only have these sizes. And this is on this paper, these questions, because it comes up every year. Like, if there's something you need to be able to do, it's find the mean from a frequency table. So that's what this F is. It means frequency. Now, you've got yourself one of those Casio calculators, the FX991s. You actually have a brilliant calculator. You may consider this being more effort than it's worth, but you could put this table into that calculator. With a couple of button presses later, you would have the answer to the mean. The question is it more hassle putting it in the calculator to begin with? If you're 9 days away from the exam, yeah, it's more hassle than it's worth. If you are not, and you're really good, and maybe you're year 10 right now, and you're looking ahead, you've got time. And it might be worth looking at it on a calculator. You're just going to input into the table and produce statistics, and it will give you it straight away. For those last minutes, we're just going to look at the theory. We're not going to look at understanding it fully. Like, to understand it, to know that this means frequency, and very easily, all you'd have to do is write these numbers out like they would be. And I'll start you off. This first column, it means that there are 3 number 1s. So, 1, 1, 1. Frequency of the number 2s, there's only one of them. There's only 1 5. There's 2 6s. So we're at 6 and 6. There's 6 7s. 1, 2, 3, 4, 5, 6. You get the idea. So if you're trying to find the mean, you've got to remember that the mean is the total divided by however many there are. And in the case of a frequency table, you've got to ask yourself, where do I get that information? Where do I get the total? If I drew it out for you like this, and I kept going, you could just add all them up. But I don't really want to write them all out like that. I can see that I've got 3 1s, so I can add them up by doing 3 times 1. I can do plus 2, plus 5. I've got 2 6s, so I can do 2 times 6, etc. I can use multiplication, because the only thing I need to know about is how many of each number there are, and that's all in this table. So the calculation you need to be showing is going to look like this. 3 times 1. You're essentially going to go through, do all these pairs multiplied together and add them up. 1 times 2, 1 times 5, 2 times 6, 6 times 7, 2 times 8, 1 times 9, plus, oh, let's do it properly. It'll be really annoying if I don't finish this. 1 times 10, and we're going to need some space. Let's get rid of frequency. We should kind of know that. You probably knew it already. Where'd that bracket come from? I see it. The 9. And then 1 times 13. Because we've done all the pairs, and if we add that all up, which we will, but not now, that's going to be the total. And now what's n? N says it means how many there are, like how much is there. And in this case, where would we find that information? We actually find it from the frequency row. Okay, that's why instead of writing the mean like this, we could write the mean. I'll just write it at the top here. X bar equals this the sum of frequency times x. We've already done that part. So this little symbol here, this means the sum. That means add them together. So the sum of the frequencies times the x's, we've done that with all those multiplications. That's f times x. And we're going to divide that by how many there are. And the way to find how many there are is the sum of the f. Because this bottom row, this tells us how many there are. So we're going to add all of those up, and I'll write it fully just this once. 3 plus 1 plus 1 plus 2 plus 6 plus 2 plus 1 plus 1 plus 1. Now all we have to do is put that in a calculator. So I'm going to go ahead and do that semi in my head as well. So 3 plus 2 plus 5 plus 12 plus 42, because I know my times tables, and hopefully I'm not going to be under enough pressure to get them wrong, and so it actually becomes a much quicker process than we think. So in this case, x bar is 112 divided by 3 plus 1 plus 1 plus 2 plus 6 plus 2 plus 1 plus 1 plus 1, 18. And we want to sort of, I guess we'll see if we could tidy that up, but not really. 56 over 9. And for those who love decimals, 6.2 recurring. Now we also ask ourselves, does that seem reasonable? The mean should be roughly in the middle. And it looks like it is. So it's okay. And it's even more so that it should be in the middle, because you can see the highest frequency is around 7. And if you look either side of 7, we've got a 2. It's really symmetrical. And then we've got a 1. Then we've got a 1. Oh my goodness. This is so symmetrical around 7. But can you see why it was slightly more towards 6 in the end? Yes, because this 3 down here versus a 1 up here, and the fact that 3 is a bit closer to 7 than 13 is. So you've got an imbalance. It's slightly leaning left. So it does make sense. Okay, let's keep going. The score on a drive-in theory test for the last 26 hopeful drivers is given below in the table. Pretty. Give an estimate of the interquartile range. Well, to find an interquartile range, we need the quartiles, right? We can do this. But look, it says this is the key point, estimate. So what we're going to be doing is estimating stuff. This is cool though. I like this. We can do this. This would be grade 9. I would guess. Maybe grade 8 or 9. It's going to be fairly tough, but we can do this. So double check we're okay with the previous one. Yep, right. Let's go. So if we're going to find the quartiles, it's just like finding the median. Let's say we've got 1, 2, 4, 10, 16. The median was the middle number. If we introduce a few more numbers there, 20, 22, we have a minimum of 7 numbers. Looking at the median, that's now this one. And from what's left either side, we'll find the median again. So that's a middle number of either side. What we've essentially done is split the data into 4 sections. Okay, and these 4 sections are called quartiles. Okay, quart come from 4. The number which sits right here in the middle of the left-hand middle, like the middle of the left-hand side, that's quartile 1. The one that sits right in the very middle, that's the median, or also known as quartile 2. And the one at the end, you guessed it, is quartile 3. And this is very straightforward to do, as you can see. If you have the actual numbers in the data set, you can just go halfway for the median and a quarter for the others. But you don't have the numbers here. What does this table mean? Well, looking at the number 1 here, it just means that there's 1 in between 0 and 5. Where? Is it a 1? Is it a 2? Is it a 4? We actually make an assumption that it is at least evenly distributed across that range. Some people might say, oh, you've used the medium, or the middle point. So 2.5, and that will represent. Okay, that's one theory. How do we do this? Well, we're going to make an assumption that all of the numbers here are evenly distributed. If we imagine that this is the 0 to 5 garden, there's one person in there, they're going to be standing right in the middle. And then the 5, that doesn't look like a 5, the 5 to 10 garden, that's got 4 people. We're going to assume that they're standing evenly spaced in that garden. 10, I don't know why I think of it as a garden. There's no one in the 10 to 15 garden. The 15 to 20 garden, we have another 5. So 1, 2, 3, 4, 5. You get the idea. So they're all standing evenly in each section. That's one assumption we have to make. So let's look at how many people there are in total here. Does it say in the question? 26. Let's double check it actually adds up to 26. 5, 10, 18, 26. It does. Okay, so for 26, we'll say n equals 26. What person would be the middle? So if we're looking at the median, the middle would be 26 plus 1 over 2. So that's 27 divided by, that's 13 and a half. That's not the median. That's the 13 and a half. That's the location of the median. Now I'm starting with the median, but we don't need it, but I'm starting with it because it's quite easy to see because it's divided by 2. It's the 13th and a half location. So that's going to be up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, getting close, 11, 12, 13, 14. So it's going to be in this section here is the median. it's going to be one of those four. Where is it exactly? And this is where we have the method of interpolation, where we're going to figure out how much extra that it went into that range. So how much did it go into that range? We have a cumulative frequency to help us. So we want a new column called cumulative frequency. And this is just where we add stuff up as you go along. A lot of people like to use this. It's useful for drawing graphs or whatever. So 1, 5, still 5, 10, 14, 18, and 26. Where have we pen? I think I was using this one. Okay, so yeah, we're at the 13.5. Now if we look at this, we entered this with 1 person, 5 person, still 5, 10 people by the end of this line. So the 11, 12, 13, 14th person all were in this section. And we're after 13.5 location. Now how far into that is that as a fraction? You can see that it's gone in 1, 2, 3.5 into this section. So if we draw it on a line like this, where we had 10 to begin, the 10th person was the end of that last one, and the 14th person there, we've gone in to the 13, let's make it a little bit further in, 13.5th person. So in terms of the proportion of what this has taken up, it's taken up 3.5, because that distance there is 3.5, out of the total, which is 4. So we can write that as a fraction or a decimal. 3.5 divided by 4. And it's not the nicest to see it in that form, so let's just tidy that up. We can times it by 2, that's 7 over 8. And 7/8 is 87.5%. Okay, so that's how far it's gone into that particular section, which is called the 20 to 25 section, but this is in terms of frequency. Now, that's how far it went in on the frequency. We want to know now what the value of y is, so we can estimate the median. Looking at this, 20 to 25, we can put this in directly opposite, because that section is represented by 4 people, if they're evenly spaced. So we want to find the equivalent proportion, which we know now is 87.5%. We'd like to know what 87.5% into the 20 to 25 is. Well, that's pretty straightforward, I suppose. We know that the whole distance here is 25 take away 20, that's 5. The whole distance is 5. What is 87.5% of that? If you want to find a percentage of a number, you just multiply it by that. So we're going to do 5 times 0.875. It's going to give us a nice 4.375. And that's how far we have to go into the 20 to 25 range. So 20 plus 4.375, and that's 24.5%. 0.375. That's our estimate for the median. We could say estimated median. This theory. If that's the first time you've seen it, then maybe it's one of those things that may be a bit overwhelming, but you are essentially just finding that halfway point. We're going to do the same now for the quartiles. So instead of n plus 1 over 2, quartile 1 is n plus 1 over 4. And quartile 3 is, you probably guessed it, 3/4. So it would be 3n plus 1 over 4. You see the 3/4? And this would be 1/4, but we just don't need to write 1. So 1/4 and 3/4. So the first one, n plus 1 over 4, is 26 over 4. 76 plus 1 over 4, sorry. That's 27 over 4. We're going to write this. We'll just write it here. We'll kind of run. I'll draw a line, which is 6.75. And interestingly, we can times that by 3, and you'll get the, like while we're at it, and you'll get the upper quartile, which is position 20.25. And I think it's important to write location so that you know that it's a location. Because otherwise you may think it's the answer. Right, where is 6.75? There's person 1. In here is up to person 5. Still not the 6th person. The 6 is in here, isn't it? So this little region begins with person number, or who we've got in there as the 10th person. Is it finished with? So we can work backwards. 10, 9, 8, 7, 6. 1, 2, 3, 4, 5. So it starts with person 6 and it goes up to 10. So those are the people that are in that section. And we're after person 6.75. So we can draw ourselves a wee diagram again. Where's my mouse? Sometimes it gets lost in the screen maze because there's a few screens and you've got to know which is the exit and entry points. Alright, so we draw a diagram, which actually I think makes it a lot clearer. And we're going to be starting where that previous one was. So that's 5 and it goes up to 10. So in terms of frequency, this top part of the diagram talks about frequency. It goes from person 5 to 10. And we are looking for 6.75, so it's nearer this side. It's that far in. See that this amount that you go into that section is the same proportion when talking about the y value. That's why we draw this. Now let's have a look at what we need to do. We need to say we want to go in to the y values the same proportion that the frequency went into the 10, because we're assuming they're all evenly distributed. So that's what we're after here. And that's going to mean for us, down the bottom, we have 15 to 20. And we're looking for this unknown here. Now we'll introduce a formula, I suppose. It's quite easy to see. We know that x, what's this distance here? This distance here is x minus 15. And if we divide that by the total of that section, which is 20 minus 15, that's going to be equal to the same thing happening up the top, which is 6.75 take away 5 all over 10 take away 5. And this can be seen as a bit easier. Essentially, you're going to end up with x minus 15. If I can add a... no, maybe not. I might not go below. Might need to stretch out some space here. Okay, we'll make it work. Essentially what you've got here, if we tidy it up, 20 minus 15 is 5, 10 minus 5 is 5, and 6.75 minus 5 is 1.75. So we'll just do this. We're going to save some rearranging. I'll save you rearranging, and I'll tell you that x is 16.75. Now doing it that way, actually, I think people like it because it's quite methodical and you can remember the formula. It takes out the need for fully understanding like we did with the median. So maybe we'll carry on that way. If anyone's got any objections, let me know. Okay, so now we're off to the 20.25th location. Where's the 20th person? Well, by the time we got to this section, we've only got the 18th person. And so the 20th person must be in the last section, the final section. Which, as we said, starts at 18 and goes to 26. So let's draw a diagram. And we're after the 20.25th person. And the section is 30 to 35. So that is in the same proportion to the 18 to the 26, frequency-wise, is in the same proportion as the 30 to 35. So we're looking to find how far it's gone in. So 20.25 subtract 18 all over 26 take away 18 is equal to x minus 30 all over 35 minus 30. We'll tidy that up a bit. Um, 6 plus 2 is 8. And then we've got 2.25. Do some work on the calculator. And we get x equals 31.40625. I'll write the whole thing. Okay, so when we talk about x, we're actually talking about quartile 3 here. And here we're talking about quartile 1. So pretty crazy. We'll keep that on the calculator because we now have to find, we actually have to find interquartile range. That was what we were doing in the first place. 4065. So we've got 31 point, so let's do it off to the right. Interquartile range is Q3 take away Q1. Very cool. We've already got that number, and then take away is 16.75. Hey, equals 14.65625. So there's your interquartile range. We do hope that in the real thing, this is definitely a big extension. and there to really push, I would say. We don't want to expect things that are too easy. Sometimes they push us a bit. But that's the way to do it. It's proportions. Okay, so how far did we go into the frequency, and we'll match that as a percentage on the actual range here of y. Okay, let's moving on. 7. A group of people from a small town called Wretchley asked for a crossing on a busy road. The council conducted a survey by asking a randomly selected 120 people who live nearby the road. Comment on the way the sample has been taken. Is it the best way to get a reliable sample? Well, firstly, are the people being chosen? I mean, we don't know how big the town is, but a small town isn't going to be more than 1,000 people, perhaps. Maybe it could be up to 10,000 people. The question is 120 people enough? Well, in statistics, as far as you're concerned in the exam, n has to be more than or equal to 30. So that looks like it's a good amount of people. And they conducted a survey by asking random. That's also really good, because that means they're going to select people at random without bias of like people. Although they did say they're going to pick them from who live nearby. Then again, is that a bad thing? If we're talking about people that are interested, it's going to be the people that live nearby the crossing that are going to have to live with it and suffer from whatever consequences there might be. What consequences might there be? Well, at the very least, these are the people that are going to be using the thing. Maybe there are not that many consequences, but we want the opinion of the people that will be actually using it. So this is not actually a really bad sample. This is really good. So the way that the sample has been taken, we would say all of those points. And I think it's important. There are a couple of these styles that say you want to find out about people, whether they like music or not, and you stand outside a music store. And obviously that's really bad, because you might not, well, let's put it this way, everyone going into that shop likes music. That's different here. Here we're living nearby, and everyone therefore has an interest in this thing, because they're most likely to be near it or using it. Or they'll be affected by the roadworks as it's being built. So lots of opinions are really good in this case. I think this is a pretty good sample. It probably is the best way to get a reliable sample. Yep, it's not a bad one. Okay, a local video game club has 2 year groups, and each member is naturally good at a different style of game, as per the table below. Okay, year 9, year 10, FPS, I guess that's a game style. So we'll write that. Game style. Turn-based games and first-person shooters, probably. Anyway, the group leader wants to introduce a new game for some variety, and will ask 10 members for their opinion. Why didn't they just ask all of them? I guess they haven't got that many people available. No, maybe they're just going to take too long. I don't know. Anyway, it's maths. We can have questions that don't necessarily make sense in the real world. We don't really live in the real world as mathematicians. And we'll ask 10 members for their opinion. Suggest a suitable sampling method and how many of each year group will be asked. Well, if you've got clear groups that need representation in different proportions, then the method of sampling is going to be stratified. It means you're going to take the same amount of proportion of people for the sample. So let's say you want a sample, oh my goodness, sample of 10, and we are going to split it, well, what's the best way? Can't really do it in that way. Well, what you can see is there are more year 9s than year 10s, right? So we look at the total year 9s, we've got 30, and at year 10s, we've got 20. So in total, we've got 50 members here. And 30 are year 9 and 20 are year 10. So what you want is more opinion from year 9, because more people in that club are year 9, so they should have more of a say. What kind of, how much more is exactly equal to what you see here, the proportions. 30 represents 60%, and 20 represents 40% of the total. So any sample that you have should use these proportions. In a sample of 10, we should have 6 from year 9, and we should have 4 from year 10. So that's how it works. That's how stratified works. You're going to pick in the correct proportions that already exist in the population, in this whole of it. So just a suitable sampling method. So the group institution again. So we want each of these people who actually are unique. And we want to know how many of each year group are going to be. Oh, in fact, we've already just done that. How many of each year group will be asked? Well, interestingly, we could work out how many of each, and then we'll talk about the year group. So this is the theory. We work out how many there are in total. We've already done that on down the bottom. We know that there's 50. And that means that all of these represent a certain fraction out of 50. Going this way, we've got 22, so FPS 22, and turn is 28. And then an overall sort of total for both column and thing would be 50. The amount of year 9s that are first person shooters are in this realm here, 12 out of 50. That's how many there are in terms of a proportion. Here, 10 out of 50. And here, 18 out of 50. So if we're talking about any individual group there, let's say you wanted to know how many year 9s from first person shooters are going to be picked, it'll be 12 50ths, which is 6/25ths. Let's just write 12 50ths of the 10. So that's how many there's going to be. It's like a proportion. And I really feel like just doing that right now. So seeing how that's going to work out. 12 over 50. And if we had a sample of 10, that's going to be, we're picking 2.4 people from here. But you can't pick 2.4. We're going to round it to the nearest whole. So we're going to pick 2 people from year 9 on FPS. Same for year 10. We're going to do 10 over 50 multiplied by the sample size, because 10 over 50 is a proportion of year 10's the FPS. And if you multiply it by the sample size of 10, you get 2. So we're going to pick 2 people from there. Here, we proportion that we want is 18 50ths. Don't be put off, it's just under half, right? It's like, what is it? 18 divided by 50, it's 36%. So we want this percent, it's 36% of people will come from year 9 turns. So if they were scaled down to 10, because we only want 10 people, we want still 36% of those 10 to be represented in the sample. So you just multiply it multiply 18 over 50 by 10. And we get 3.6. But we can't have 3.6. Let's round it to the nearest whole. It's 4. And we've already done 10 over 50. That's 2. Now what you'll notice is that all these numbers will add up. 2 plus 2 plus 4 plus 4. That adds up to 10. So we've got our 10 members. If we were doing it individually, this is how we would tell how many of each demographic we would be picking. So you can see that 18, that's the most, the turn-based year 9s. So therefore we should have more people in our sample from there because they represent more of the population. Whatever this is for, this new game, we're hoping to satisfy more people. So 4 come from that section out of the 10. Anyway, let's look at the actual question because we could get carried away there. All it says is suggest a suitable sampling method, stratified sampling. We've actually carried it out. How many of each year group will be asked? We actually don't really care about individual strata. You see these individual boxes are called strata. We only care about the year groups. So let's use our pen again. The total for year 9 that are going to be picked on the left hand side column, you can see there was 2 plus 4. So 6 will be year 9. And year 10, 4. But we could have done that earlier when we were off to the side and we were saying 30 to 20. If we're going to split this into that, because we got 30 and 20 from the column totals for year 9 and 10. I'm going to split this into that ratio. Essentially, we cancel it down. It's 3 to 2. And 3 to 2, if we times that by 2, we get 6 to 4, which has a total parts of 10. So this is going to be the ratios. That's 60% to 40%. But more than that, this is exactly the numbers that we're after. 6 people from this side and 4 people from that side. But yeah, anyway, that's stratified sampling. It doesn't matter how you get to it. This is actually quite a nice way when you're looking at individual strata. This is all we needed. There are many ways to do sampling, by the way, and that's just one of them. Okay, the number of hours that 2 set of laptops will last, I think that's meant to be 2 sets of laptops will last on one charge is shown below. Okay, so set A, so these are hours, so 2 hours, 5 hours, 9 hours, 10 hours. I find it helps to say stuff like that, so if it's in hours, just say it. Set B is 2 hours, 3 hours, 6 hours, 7 hours, etc. Okay. Draw a box plot to display both of these on one graph and compare them. Okay. Well, in order to draw a box plot, we need some information for each. So we're going to need the minimum, and that's 2. We're going to need quartile 1, quartile 2, the median, quartile 3, and the maximum. So the maximum is 15. The others are a little bit harder, but it's okay, we can do it. So we've got the minimum and maximum. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 plus 1 is 13, divided by 2 is 6.5. So 1, 2, 3, 4, 5, 6.5. There is the median. So it's 8. And of these numbers that are left that we have not worked with, where's the middle? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Good, it is them. Where's the middle? We got 6 numbers, and we plus 1 is 7. The middle is 3.5. So 1, 2, 3. There's the half there. 1, 2, 3, and there's the half there. So we have our quartiles. What's in between 6 and 6? 6. It feels weird in the exam if you're stressed, but confidence. In between 9 and 9 is 9. Okay, let's go set B. Let's go. We've got I don't know if this saves time. We'll find out. Oh, I thought I copied it. No, this is already slowing down. Copy and paste. Where's paste? You know what? Just get on with it. Minimum, again, is 2. Maximum is 17. Quartile 1. Median and quartile 3. Okay, so we've got 17 and 2. And because it's the same numbers, like the same amount, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 6, 7, 8. Yeah, it's the same amount of numbers. We can go to the same location. So that was 6.5. So 1, 2, 3, 4, 5, 6.5 is in between. 1, 2, 3, 4, 5, 6.5 is in between here. So here's our median. And the 6 that are left each side. How do we find the median when it's in between two numbers? 7 and 8 was exactly the halfway point, so 7.5. Let's use this moment to talk about finding the halfway point between two numbers. You want to find the halfway point between 52 and 74. That's pretty nasty. All you do is add them together, which actually is not too bad. It's 126, and divide it by 2. That's 63. And there you go, you got the midpoint like really quickly. So, top tip, we're going to do that with these. 7 plus 8 is 15, divided by 2 is 7.5. Okay, the median for the other side is in between 3 and 6. You know what to do. 3 plus 6 is 9, divided by 2, 4.5. And it's also on the right hand side in between 9 and 13. 9 plus 13 is 22, divided by 2 is 11. Okay, we've got our statistics. A statistic is a calculated bit of information from a raw data set. And we have 5 statistics for each. These are what are necessary to draw a box plot. Have a quick look at what our range is. We need to cover up to 17 and down to 2. So we need to draw a line that's going to be good enough for that. And I think we're up for that. We can do that. Yeah, okay. You go there. That's very sensible. All right. Let's say here is 0. Let's say here it's 20. Why not? And so the middle of that, the very, very middle, I think it's time for a drink. Draw a scale from 0 to 20. Give you time. Yummy. We want the very middle. I think this is the way I'm going to play it. That's roughly the middle. There's 10. Going to halve it again. When you haven't got any ruler like squares or anything, this is the best way of doing it. Half, half, half. 1, 2, 3, 4. 2, 3. That's no good. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I get this pretty evenly spaced, and I'm happy with that scale. Now, what are these? These are number of hours. For a battery. No, we'll just say hours. In brackets. We will have this, actually, it's better. We're going to say battery life. Alright, and we're going to plot now. So for each of these statistics, we want a vertical line in line with one of them. So I think what I'm going to have to do is zoom out, and we'll have to deal with it. So we'll start with the bottom one, because get it out of the way. 2 and we'll circle it as we go along. So quartile 1 is 4.5. Median is 7.5, so 5, 6, 7.5. You're going to do this with a ruler, I hope. Median is... Oh, we've already done it. Sorry, quartile 3 is 11. And max is 17. I think my box plot's going to look pretty funky and thin. Sometimes they can be pretty chunky. Do this with a ruler, it looks so much better. And lastly, the other one. We'll label this B. So A is going to go above. So that's minimum. Quartile 1 is 6. Quartile 2 median is 8. Where's 8? 6, 7, 8. Quartile 3 is 9. Close. And the maximum is 15. Okay, very nearly there. They have to be drawn on the same scale. Otherwise, this isn't going to work. So, what we need to be aware of is that comparing two box plots, there are only 3 measures that are really, truly considered. And we'll just label them here. So we can talk about median. We can talk about interquartile range. Or we could talk about skew. The rest are not really important. Don't talk about median. Don't talk about quartiles being different from each other. These are the only ones that really make much sense. And they are very solid. There's no point in worrying about getting the full plethora when these are the 3 top ones. Okay? So very easily we're going to say that the median in A, which is... It might be easier to get some of the numbers in here. I'll just do them all. Why not? The median in A, which is 8, put in brackets, is more than B, which is 7.5, but not by a lot. So that would be evidence to suggest that, well, they're called sets yeah, the set A lasts longer in general. Okay, so there's your 1 point, because you've got to look at how many marks this is worth. If it's worth 4, you're going to try and make 2 points with 2 reasons. I mean, I would probably make all 3 points: medium, interquartile range, and skew, but sometimes they're the same. Right, so let's have a look at interquartile range. There's definitely different. So the interquartile range in A, which is the difference of 9 and 6, which is 3, is less than in B, which is that 4 or 3.5? What's B doing? What are you doing down there? Yeah, it's 4.5. And so B being 4.5 to 11 is, which is 6.5. Which is evidence to suggest. I mean, what would it mean? I mean, I'm going to say it means more reliable. So group A is more likely that you can rely on them to last between 6 and 9 hours. Typically, things that are predictable are good, because they're not going to surprise you and you can plan ahead. You've got a bigger interquartile range with B, which means that some will last quite a while, but there's more of a spread around that, so there are some which will last a lot less than in A. And it's not necessarily about the minimum or maximum, it's necessarily about the box part, which represents most of the people, which is 50% of them. So in that regard, I'm going to say that the battery life for A is more reliable. Oh, evidence to suggest is more reliable. That's a good one. And then finally, we have the skew, which is a great one. So the skew in both is symmetrical. What does that mean? Well, we only need to look to the square. Okay? So this is the only place we're going to look for skew. And what about it? It's where the median is. Now I'm going to tell you there's quite a lot of movement that it can make before it's considered positive or negative skew. So this 1 and B is obviously quite near the middle, and I would still consider it a symmetrical skew, like an even, all the way up to that red line. And you'd probably get away with it. Same with this one up here, right? So if the actual middle's here, like, you could get away with it being even in this tolerance. Now there are some calculations that will take statistics and calculate a skew using a number of different ways, using quartiles, using mean, median, mode, or such statistics. That gets a bit more precise. But in this case, we're just looking at it. Is it roughly in the middle? You could say that A had a slightly negative skew, suggesting the tail is slightly to the left. And you'd probably get away with it, but you could also get away with saying that it's an even symmetrical. Skew in both is symmetrical. And that's it. Oh, it was red for the final dot. No, sir. Okay, so that's it. And what we've managed to do is compare the two distributions. Can I just take the time to give you a real good bit of advice is to always include numbers, okay? And that makes it very precise. That makes it a good statistical report. Okay, so these are some glorious questions. Let's have a quick recap. We looked at plotting and sketching and doing linear coordinate geometry, all good stuff. We looked at averages, frequency tables, statistics, a little bit of an extension in there, sampling method, stratified sampling, good recap, and box plots, all of which are guaranteed to come up if they haven't already. These ones especially, perpendicular lines, parallel lines, definitely the mean will come up. It's just where. So make sure you know the definition and you've seen it in all different ways that you could. Very likely that it comes up in some sort of table. Not this one though, frequency table. So number 6 is my pick of the day. I've never seen it not be in an exam. Sometimes the x's are not 1, 2, 5 like whole numbers. Sometimes they're like this down here, they're ranges. And what's the difference if you were asked to find the mean from this table versus this? Well, you'll do the same method as up here, but instead you're going to pick the midpoint of all of these. So 2.5 times 1, 7.5 times 4, 17.5 times 5, 22.5 times 4, etc. And then add them all up like we did here. And then divide it by how many there are. Well, you just add up the frequency again. And then you get your estimate, but it is just an estimate. This is an exact number because you know the exact numbers. This down here is an estimate because it's like it's a range. We don't know where they are. Really cool method here with the proportions. Can revise that anytime with this video. And a bit of sampling. My favorite sampling method, stratified by group. Although we know that there's many more. There's simple random sampling, convenience sampling, quota sampling, systematic sampling. There's many. Stratified is probably one of the more useful ones. It's clearly bias in a way because at this level you are defining groups within the population and you're saying that those groups are different enough that we need a representation. How do we pick the people? Well, once we decided that we want 2 people from year 9 in the FPS, those 2 people get picked at random. And there are different methods for picking at random, but if you're ever in the exam and you want to pick numbers randomly, what is the best way of doing that? Don't get fancy and think about all the different computer programming ways that you could think of, but just pick names out of a hat. Good old tombola. And that's typically one of the easiest ways of getting that sort of random element. And lastly, we are looking at Boxplots, which one of my favorites. Everything has a box plot. If you carry your study on far enough, everything has a box plot. Even if you're plotting a bar graph. I'll show you what I mean. So if we draw bar graphs, we just draw bars like this, right? But because some of these statistics, when they were calculated and collected, they may have errors in terms of how they were collected. So each one of those heights has a distribution of error. where it's most likely to be where it currently is in the height, like in terms of height. But there's a chance that we made an error as high as there, or as low as there. So box plots are really nice ways of, I guess, staying humble. The error occurs and that we may not have the perfect answer, and there's some sort of tolerance. Clearly, if we had a bar chart which was small versus a bar chart which was really big, we can see that reliable data, which is this one, is much more useful than this one. Because if your bar chart, if your box plot is really small, that means there's not much wiggle room, and actually the location of that height is really good. Whereas with this one, it could be as high as up here or as low as down there. What really are you saying about the data when you say that it's here? Because you could be very wrong. Yeah. And then lastly, comparing box plots. You want to do just these three measures. Okay. I do believe though it will they in the exam will accept range. They've been pretty generous about that, but best to avoid. You know, if you've got a choice, may as well pick the best. Okay, so this is. Let me just have a look at the date. Okay, so 9 days out means that the next one is going to be 2 days out, and that's going to take us to. Well, actually, no, it won't. It's here. The next one out, yeah, it's going to be 2 days out, which will take us to Monday. So you've got another whole week, and I'll put another poll up in the YouTube community section on which topic to go. If no one picks anything different, I'll go with the highest one from the previous poll, which was trigonometry in 3D and exact values, which actually, you know, it can appear on both papers. So nothing safe of whether it's on a calculator or not, although they probably won't be testing the same skill twice. So really have a think about what happened on that paper one and what topics are left to come up and which are less likely to occur. Sometimes they occur twice in slightly different form, but that might be a worthwhile analysis. Anyway, best of luck, and I'll see you next weekend.